Hey guys, Professor Doney back here. We are now doing some problems on Newton's universal law of gravitation. Okay, Newton was the apple guy, came up with the idea of gravity, maybe not came up with, but looked at gravity, the apple falling supposedly. Would it fall from the top of a tree to the earth? Would it fall from the top of the mountain, from the moon to the earth? And then he expanded his idea of gravity out into universal, or to the universe between large bodies. Okay, and so if we look at Newton's law of gravitation, it's the force of gravity is big G, that's universal gravitational constant, mass 1, mass 2, over the distance between them squared. Now that R can sometimes be a D, it can be an L, it's really just the distance between the two. Okay? Now they refer to this as the inverse square law because it's a square value inverted. This shows up again in physics 2 when we talk about Coulomb's law and stuff like that. So it's really telling us the gravitational attraction between two objects. So let's just do an example here. Little silliness. Between you, the gravitational attraction between you or me, 100 kilograms, and, well, technically I guess that should be green, and a Mountain Dew. Alright, and let's say the Mountain Dew is 1 kilogram. Just to have some easy numbers. Now, because of Newton's law of gravitation, both masses will pull each other. This is the person pulling on the Mountain Dew, and because of Newton's third law, equal and opposite action-reaction, the Mountain Dew will pull on the person equally. Okay? Equal in magnitude, opposite in direction. Now, it doesn't mean that they will both accelerate towards each other if we're out in space or on roller skates. Because this has a much larger mass, that little force will have a smaller acceleration, but this bigger force on the Mountain Dew, which is smaller, would have a bigger acceleration. Anyway, so let's go through here. Force of gravity on that universal law of gravity, the universal constant is 6.67 to minus 11. That is a constant, that's why we use a big capital G. Each mass, there's 100, there's the other mass, which is 10. We divide that by a distance. How far away are they going to be? Let's make we'll make them 6 meters apart just to make the math a little easier. Okay? So that's going to be, well, it doesn't really make the math any easier, but alright, let's change it to 10 meters. That definitely makes the math a little easier. 10 meters apart. Alright? And that 10 meter is squared. That's a big mistake people make, usually forget that. Now, depending on what calculator you have, it's easy or hard to put in these scientific notation, this part. Sometimes it's an e to the minus 11, sometimes you use caret or the exponent. Here's what I like to do. I like to start out and multiply all the coefficients first. Not coefficients, but the numbers outside here, the prefixes. Deal with all these first. So 6.67 times 10 times 1,000, that's 10 squared. Below this gets rid of this. That's times 10. This becomes 66.7. And then what I do is just add the scientific notation to it. So that's a quick and easier way, I think, to deal with scientific notation. You leave the answer that's fine. Now, what if we go further and say, all right, we're going to put our Mountain Dew on some rollerblades or casters, and we want to find out its acceleration. If we stand still, so we're fixed, and we put this on something that's frictionless, what we do is say, okay, that force on the Mountain Dew of its mass will cause an acceleration. Okay? Call positive that way. That force, we just found out 66.7 times 10 to the minus 11 equals the mass, which is 1. Acceleration of that divided by 1, so 66.7 times 10 to the minus 11 meters per second squared. Really slow. We could take it a step further and say, okay, well, how fast will it be going after so many seconds? We put that acceleration in there. If it starts from rest times number, however many seconds, we could find out how fast it's going after so many seconds. Alright, so that's, I didn't finish the numbers there, but you get the idea of how we come up with a force which causes the acceleration, causes the move. So, hope that helps you out with Newton's universal law of gravitation. See you in the next video.